My name is Tan Tui and my ZID is 5415197. This is my video for the PHYS 1160 experiment titled Understanding the Solar System. I used the PHET gravity and orbit simulation to observe the motion of planets and moons, and to explore Kepler's law by creating and analyzing different orbits. Kepler's first law tells us that planets move in elliptical orbits with the Sun at one focus. The second law states that a planet sweeps out equal areas in equal times, so it moves faster when it's closer to the Sun. And third law shows that the square of the planet's orbital period is proportional to the cube of its orbital radius. This means that planets further from the Sun take longer to complete an orbit. In the simulation, I compared a planet-moon system and a star-planet system. In both cases, the two bodies orbit their common center of mass. However, in the Sun-planet system, the Sun's movement is small due to its large mass. In the planet-moon system, the center body motion is more visible. This helped me to understand that all gravitational systems involve mutual motion, not just operating a fixed center. In the simulation, I observed that the distance between the Earth and the Sun was about 2 great squares. Since the average Earth-Sun distance is defined as 1 astronomical unit, I estimate that each great square represents approximately 0.5 AU. This rough estimate helped me set up orbit as specific distances in a later task. And I create 4 near-circular orbits with radii of 0.5 AU, 1 AU, 1.25 AU, and 1.5 AU. Then I measured the time each orbit took to complete one full revolution. As expected, the orbital period increased with distance, consistent with Kepler's third law. The relationship between distance and time becomes more obvious when plotted in a table. Since the orbit is not a perfect circle, there will be errors in radius measurement and the digital accuracy of the simulator. The data will have certain deviations. I set up circular orbit at distance of 0.5, 1, 1.25, and 1.5 AU, and recorded their orbital period. As the orbital distance increases, I observe that the period also increases. This trend is consistent with Kepler's third law, which describes the relationship between planet distance and its orbital time. I looked at a diagram of the solar system and noticed that Mercury is the closest planet to the Sun, and Neptune is the farthest. Based on their position, we can understand that Mercury moves faster in its orbit, while Neptune moves slower. This matches Kepler's second law, which tells us that planet closer to the Sun moves faster. This experiment helped me visualize how gravity and orbital motion are connected. I learned how planet and moon moves around a shared center of mass, and how orbital speed and period change with distance. I also saw how measurement error and simulation settings can affect results. Overall, this experiment deepened my understanding of celestial mechanics and gave me a more intuitive feel for Kepler's laws. Thank you.